you have these cycles, and what happens if you compute the product between these two observations? And remember, it's zero mean. So the product is plus by plus. It's still a plus. And what happens if you compute the product between these two observations? The product is a minus times a minus. It's still a plus. The only situation in which you get a result that is negative is when you cross the mean. But if there is dependence, the crossing of the means are very limited. Now, let's look at this second situation. And so here you have a crossing of the mean, here you have a crossing of the mean, a crossing of the mean, and etc. And therefore you have many crosses of the mean. The result is that, of course, you have a situation in which you don't have crosses of the mean, but they are compensated by the many crossing of the means. So you have plus, minus, plus, minus, plus, minus. And you sum here plus, minus, plus, minus. The result is zero. So in this case, you have a correlation that becomes positive because you have more plus, 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 only one minus. In this case, you have some plus, some minus, some plus, some minus. And the product is zero. Let me show you a third example. And the third example is a time series that regularly is like that. So basically, here you have a minus, a minus, a minus, a minus. The correlation becomes negative. Negative correlation means that you still have memory. But the memory is such that to an high flow succeeds a low flow. To a low flow succeeds an high flow. This is something that is not physically reasonable, but from a mathematical point of view, it's reasonable. It means up and down, up and down, up and down. So with up and down, up and down, up and down, you have negative correlation. With long ups and long down, like in an hydrograph, you have a positive correlation. With a random mix of fluctuations, you have zero correlation. Okay, so let's take our river before we make the back time series. And let's look at the correlation coefficient. The only problem is that I have to remember how to get it, but I think it's ACF, POD3. But if I do this, I only get a graph, which is not what I want. And I think it's like this. Let me try. Yes. Okay, this is the correlation coefficient with lag 1. So please don't be concerned about the fact that I put an index 2 here. This is lag 1. Trust in me, okay? 0.95. If I increase the lag, what would you expect? A decrease of dependence. Okay, let's see if it happens. This is the River time series. It's a real, this is the time series, the logarithm after logarithmic transformation and after deseasonalization. You see that still there is a lot of memory. It decreases, but still there is a lot of memory. Look, I told you that there is a graph that is produced by this function. Let's see it. This is what is called the autocorrelation function. It's for varying lag from 0. It starts from lag 0 here. We will discuss later what lag 0 means. From lag 0 to lag 45, this is something that Hard decided by default. He stopped it here. You see the correlation coefficient. It goes from 1 to 0.4. And this is a real time series. So you can clearly see that the presence of memory is visible here. Now let's make a counterexample. The counterexample is a completely random time series. And let me generate it. So let me say random 1 is equal to R norm 30,000. And as I remind you, this is a random Gaussian time series with the mean 0 and variance 1. So, autocorrelation. No, sorry. I made a mistake, random one. 0. Let me increase. 0. Let's look at the function. 0. So you see the nice idea. By computing the product between subsequent observations, it's a very simple computation. We get an estimate of the dependence. And look, R also gives you, if you look here, the blue lines are the confidence bands of the zero value. It's a statistical test. It means that if you have every correlation coefficient that is comprised between the bands, the series is random, no dependence. If you exceed the bands, then you have dependence. And there is some tolerance. The theory says that over 100 coefficients, you can tolerate 5 of them outside these bands. Okay, coffee time.